I would like to kind of have a feel of how you're feeling. I know when there you feel really great. What about the rest of you? How are you feeling? Just put it in one word. For me this morning, I feel really energized. So the word is energized. Let's see. Okay. Dario says, charged, fired up. Wow, that's really good. I like the positivity. Uh, who else is hungry? I was hoping someone would say I'm hungry. So everyone, tell us how you feel. Now, was okay motivated, Noble? Uh, whilst our friends are telling us their awesomeness, is my screen visible? You can give me a thumbs up. You can say yes. You can. Okay, Terrence, you are alive. That's kind of really high. Morale high. Wow, that's. I like the positivity. Excited. Someone says great. Okay, I'm hoping someone will copy somebody's word, but then okay. So I see a thumbs up means my screen is visible. So hello everybody. For those of you who were here earlier on, you have seen me before, probably heard my voice. My name is Joseph Tete, and I am a technical trainer, or I say a cloud trainer, and I'll be here to just help you understand, to the best of my knowledge, networking in AWS. Hello, Sir William. So I have my bosses here, William. So you've met all my bosses. I'm the last born coming in before uh, the cycle ends. So welcome today. But before we jump into the concept of the day, I want us to just have fun. What is a network? I like to ask simple questions, so anybody can use the chat or unmute and just tell us, what do you think is a network? Am I audible? Correct. So I see some people are chatting. Someone can just, please, there's no wrong answer here, okay? Don't let anybody scare you. Think of it. It could be LinkedIn, it could be whatever you think it is. What do you think is a network? Okay, I see the area says web of connected. So web of connected. It's not word, it's web. Connected devices. Network is a connection of devices talking to each other. So devices talking to each other. Okay, it's a way of communication between devices. Okay, I think the idea is there. So when we say a network, usually we are talking in terms of computing and not social media. So in social media, just like we have networking where you look at something like Facebook, Twitter, LinkedIn, they are networking, but for human beings. The same way we have computers, and computers, before they can talk to each other, so if this is a computer, so I'll be drawing really ugly structures. If this is a computer, before they can talk to each other, they need to connect to each other. They need to connect to each other. And this connection can be physical or it can be wireless. So which one have you used here? As we are here, we are on a network, in fact, and everyone who connects to this classroom, who joined this classroom, is on a network. So are you using a physical connection to talk to the other computers, or you are using a wireless connection? Which one are you using? Okay, William is using wireless Wi-Fi. Okay. All right. Wireless. Everyone is using wireless. Everyone is using wireless. Okay, everyone is using wireless. I think the days of wired Ethernet it's over. Everyone is going wireless. All right, thank you very much. So now we have established. Okay, Nobo, tell us what you are using. I like the divergence.
An Ethernet cable.
Oh, that's super good. That is super good. So I'll try to just make a small illustration for you before we go on. So this is your computer, and you are using either wireless or wired to connect to it to wireless or wired, and we call it Ethernet cable or Ethernet, whatever, to connect to your another computer from your internet service provider, a router. I will say a router, and then that router links you to connect to, I will call this the internet. And then through the internet, you're able to talk to us. This is what happens in there. And keep this idea in your mind as we go into AWS. Wendell, you are on dial-up. That's really weird at this stage of our civilization. But anyway, good for you. All right. So today we are going to look at the fundamentals of networking in AWS. We will talk about Amazon VPC. We will look at what subnets are, internet gateway, route table, IP addresses, and other terminologies that I will try to see if I can bring to our local understanding, not necessarily in the jargons. All right, let's come back to this place. And then everybody try your best. How does computers identify each other on a network? PC1 is there trying to talk to PC2, and probably there is another one here called PC4. So how would PC1 knows, okay, which one I'm talking to? Probably it wants to talk to this one. How would it do that? Okay, thank you. I see MAC address and IP address. Thank you. Thank you. That's really cool. So we have IP address. And then we have MAC address. I want to hear someone's voice. IP address, MAC address from Isaac and Brenda. Okay, so what is an IP address? Okay, go on, Wendell.
Basically, it's a logical location of, or a logical identity of a device over the network.
Logical identity of devices over a network. That sounds really nice. I was hoping you would say it's a weird number that identify devices on a network. But good, everybody here has an IP address, and that is so true. So when you go onto your computer or your phone, you go to Wi-Fi, you will see under properties, you will see you have an IP address. Usually you could see something like 192.168.1, probably I want to put, and then something after it. This is what an IP address is. And it is a number uniquely assigned to devices on a network. What about MAC address?
So a MAC address, maybe it's like a physical address for a device on a network. So it's the physical address of the device.
Okay. Thank you. That's, you see, a physical address. All right. So who has been able to
I think, hello?
Go on, go on.
Hello. Yes, yes. So I would say an IP address is a logical address. Physical address could be like a MAC address.
Okay. All right. For those of you who understand logic, I'd say virtual, and then we could call this physical. Thank you, Jacob. But you know, how come we are calling MAC address physical address? It is because if you tear apart the computer, your phone, your laptop, any computer that can communicate, there is something inside that we call the network adapter, or those days we call it a network card. And that card is what enables your device to be able to connect to a network. So that card needs to have an identity. And the identity of that card is what we call the MAC address. So please, if you have any question, just put it in the chat. I can see the chat, raise your hand, and then we go. And if you are cool, you just give me a thumbs up and then we continue. All right, so talking about IP addresses, in networking, IP addresses are very, very important. And that's why I have to use some few minutes to let us understand where we are coming from and where we are going. So when you pick an IP address, we have several types, but I'm going to talk about two types. We have what we call the 32-bit IP address, which usually we refer to as IP version 4. And the IP version 4, which means we have different versions. The 32-bit just comes in from these numbers. So look at these numbers. They are broken into pieces. And each piece is supposed to contain a byte, or what we call 8 bits. So think of this number here. I have 172.31.0.0, and then there is a strange /16 here. We will explain it. I know some of you are already aware. Now this is in decimal. So if we convert this to binary, that is base 2, we are going to have ones and zeros. And when you separate them just as they are, you see that we will have about 8 zeros or ones, or a combination. So we have 8, 8, 8, 8. When you add all these, you get 32. And that is how come we say it's 32 bits. Now, IP version 4 is what we use in there. And that 32 bits can tell us the total number of IP addresses that is available, which if you compute, we have about 4.3 billion IP addresses, and that is what is on the internet. So every device on the internet falls in this IP address range, which is broken down into classes. I think you can read more about classes of IP addresses. So I'm not going down the rabbit hole. As I told you, I'm going to end here. Now, there is a /16 here. What does that number mean? What does it tell us?
So once again, yeah. So Jacob here. So /16 gives us the number of subnets, the subnets that we can have on that network, or we can also tell us the subnet mask.
Okay. So if you are new to IP addressing, don't be scared. So subnet mask, well, just think of it. The /16 here simply tell us the total number of IP addresses that is available for our network. And we call it a subnet mask, or in any way. We are not diving into that. All right. So when you see /16 here, it means we have about 65,000 IP addresses in here. You can talk about that later. That is one type of IP addresses. We also have the IP version 6, which is not displayed here, but that was an improvement upon the IP version 4. And the reason is that IP version 4 was thought to be enough. But we realized there are more than 4.3 billion devices around. Light bulbs are having IP addresses, cameras are having IP addresses, houses are having IP addresses now. We call them smart houses. You go into people's houses and their fridge, the fridge is smart, the TV is smart. They are all using these IP spaces. So IP version 6 was created to address the limited space of IP version 4. Okay. So here you will see that IP address is crucial to a network. Here we have our network A here, our network A, and we have, think of this as computers or servers. And these computers, we are using these IP numbers or these IP addresses to connect to them, to be able to uniquely identify them. And then if I want to talk to them, I could use this number and then send that traffic or that packet to them. So that is how IP addressing work. Now, as I was saying, this notation, we usually refer to it as the CIDR block. And it's just a way of declassifying IP addresses. History, when IP addresses started, we have to classify them into classes, class A, B, C, D, E, and that gives a lot of limitation. So the CIDR or the classless inter-domain routing was introduced to declassify it to allow you to easily tell the number of IP spaces you want by using this slash number. So when you see slash 28, what it simply means is that how many bits do we have in IP version 4? Who can remember? How many bits did I say? 32. So if you see slash 28, it simply means take 32 bits, deduct 28 bits from it. What do you get? You get 4. So it means you have 2 raised to the power IP spaces available, which is 16. It's very simple. Now, what about slash 20? When you see that, it means you have what? 32 minus 20, which is 12. 2 raised to the power 12. You have 4,000 IP spaces. Why is this important? That is what I want to say. Now, think of this. I have an image here. Everybody is going to tell me what they see in this image. I just put this image, and I think I like this image for really weird reasons. Is my whiteboard visible, Terence and the class? Is it visible?
It's visible.
Okay. So as you can see, it's just something like some real estate where we have houses, okay? Houses all aligned properly, and then there is a main road passing in front of these estates. Now, if you are to assign house numbers to these houses, those represent the IP addresses, and then you could think you are going to assign these numbers. So if you have limited number, say you have only 6 numbers, it will be difficult to assign it to them. So when you are dealing with IP, you need to know the number of or the space that you want, so that you don't end up having limited number of IP addresses, because you cannot extend them. You have to recreate the space again. And that is why it is important for us to know to determine these CIDR blocks. So as you can see, the CIDR block 16 have the largest IP spaces, 65,000 IP addresses. And then these 65,000, you can break it down into smaller parts again, and we'll be looking at that. Any questions so far? Thumbs up if you are good. Question if you have some, or you can use the chat. All right, some people. Charles, are you here? I want everybody's attention to be here, because now we are now diving into cloud.
I'm here. Come around.
Great. Great.
Present, sir.
All right, thank you. So let's go into AWS. Now, in AWS or in cloud, or in any form of computing, we are going to use computers or servers or different computing devices. And we need to know how we can create this network. So in cloud, if you want to deploy resources, you need to create what we call what? A VPC. You need to create what we call a VPC. So VPC is just a logical network that you create so that what? You can deploy your resources in there, isolate them from Brenda, from Isaac, from Jacob, because we are all using the same data center. So we should be able to create a logical grouping or an IP space for our resources. So look at this. We have AWS data, the global infrastructure, where we have regions. I know you've been taught that. Inside of regions, what do you have? Don't let your teachers down. Inside of regions, so we have regions. Inside of regions, what do we have? I see zones. We have a lot of different zones. Don't be confused. Okay, be very specific. What do we have inside regions? Okay, I see AZs. Okay, so in AWS, and let me scroll down. So in AWS, we have regions, and inside of the regions, Isaac is right, we have availability zones. Now, these availability zones, inside of the availability zones, what do we have? What do we have inside of it? Okay, so we have data centers inside your availability zones. Don't forget this, you'll be tested on all of this in the exams. So you don't learn for fun, we learn to recall. So for you to deploy a resource, you have to define which region you want to deploy it, and then you create that network in that region. And in this sense, we say you create a VPC, which stands for Virtual Private Cloud. So you are creating a private space inside your region or in the cloud, and you have to specify a place. So it could be in South Africa, it could be North Virginia, Ohio, it could be in Frankfurt in Germany, it could be another data center somewhere. So don't forget your AWS global infrastructure, global infrastructure that you learned right from the beginning. Now, we create a larger network in a region, and we can break that larger network into what we call subnets. So remember, we created an IP space. Let's say we have 10.0.0.0/16. So this is saying that we have 65,000 IP addresses. We cannot let them all be. So we can break them into segments. And this segment is what we call subnet. So this subnet reside in availability zones. So we can say, okay, we want to deploy this resource in this availability zone, where in that there is a data center. All right, so think of this. Again, let's go back to our image. So this image is our VPC. So the entire image is our VPC. And it's in this region. What is the dominant region in Uganda? Kampala? Is the capital city Kampala?
Yeah,
Yes.
yes.
Okay.
Yes, capital city.
Okay. So I want to deploy a server in the cloud, and I want that server to be in Kampala. So the region I'm going to create, and think of that network as a piece of land that is given to you to what? Develop. So this is in Kampala. So the region in this case is what? There's no AWS region in Kampala. Is there? There's none, I'm sure of that. But then let's say Kampala. All right. So we say, okay, how many houses or how many resources are you going to use? And we think of it and we say, okay, I don't know. So what do? We choose the biggest IP space. So we say, okay, we are going to use this IP address space, and then we are using the CIDR block /16, so that we have 65 spaces available anytime there is a new IP device that need IP, we can assign. But then our resources, we notice that just like these houses here, see, these ones are pretty accessible. Anybody can walk through the main gate here and go into this, go into this, go into any of them. So we can segregate that. And that is the reason of breaking down the IP address. But you see, these ones here, look at this part. They are pretty hidden. So maybe those people there are like, who here is very noble. They don't want anyone, unauthorized entity, to come into their home without invitation. So they are hiding themselves behind the public space. So they are private. So we can now create demarcations, okay, segregations, and then we say, okay, this is public space. So we give it a public IP space. We say private. These people are private. Maybe they are the rich folks in this Kampala city. And then we have the another public space here. So you see, we use all this analogy in cloud. So if you don't take anything away, or what I'm saying is that a VPC is a logical network or a virtual network that you create in the AWS cloud. And then these VPCs are bound to what? A region. So VPCs are bound to an AWS region. It means you can deploy a VPC in only a region. And they provide what? Isolation for your workload. And this way you can control access of traffic in and out of your VPC. Now, I also mentioned something about subnet. Who can recall? What did I say about subnets? Subnet. If I'm moving too fast, let me know. Who can remember? Am I audible?
So,
Yes,
yes,
Isaac,
Yes.
go on.
Yeah, but I think you said that
So,
subnet is assigned to an availability zone.
Okay, they are deployed in availability zones. Okay, Jacob, go on. Thank you, Isaac.
yes. So, I think, but like, are you talking it in terms of AWS or general networking?
General networking is
Okay.
the same.
So,
Yes.
yeah, the subnet will help us know how many hosts we can have in a given network.
Okay. All right. Thank you. I see Ray also says deployed in availability zones. So let's build up. We have a large network which represents this box, which we call what? VPC. And it has a very large IP addresses. So let's say 65,000 IP addresses. And then we can break these IP addresses into smaller segments. In this case, 1, we can break it up. 2, we can break it up. 3, and then we call them subnets. So this is subnet A, subnet B, subnet C. Say, all for different use cases. As you saw in the real estate, some can be public and some can be private. Some can be public, and it goes on. And we will look at how we make a subnet public or private. So let's see my AWS account. I think it's high time you see what I'm talking about. So is my browser visible?
Yes.
Okay, so in AWS, I can go into the services, and today, I know this is not new to you, but we are looking at networking and content delivery, which is here. So you see, we are looking at resources under this category. Now, if I click on that, you can see I have something called VPC here, the AWS Virtual Private Cloud, or you can just type VPC in the search bar and you have it there. If you are like me, I'm pretty lazy. So what I do is that I pin them. You can see I pin the most frequently used services on my browser so that I don't have to be searching or not. I just right click and I'm there. So when we go to VPC, I want you to focus here because this is where all the interesting information is. On the left side here, we have all the things we need to create a VPC, a network. So we have the VPC, which is the larger network. We have the subnet, which is the smaller broken pieces of the larger network. Then we have route tables. We look at them, and then we have gateways. All these aid our connectivity in the cloud. So to create a VPC, as you can see here, I can click on create VPC. Then I'm going to say I'm going to create only VPC because we don't know what the address and more is at the moment. Give my network a name, so I'll say Kampala City network. I want to be very precise. Network, and then I am being asked, what is the CIDR block? How much IP addresses do you want? Okay, and I know there are a lot of black spots in the IP addresses, but you have to take it away, read the documentation on IP. I think one day we have to organize IP addressing as a course. So there is some placeholder here. I'm going to use that placeholder to say 10.0.0.0, and I won't use 24, I will use 16 because I want to have a lot of IP space. That is all I need. It will ask, do I need to use IP version 6 or IP version 4? And I said, no IP version 6. It means I'm using only IP version 4 here. That's all I need. And then I click on create. So as you can see, I've just created a VPC, a larger network called the Kampala City network, as you can see here. And this is the IP spaces that I've given it. If I go to my VPCs, hopefully this is the only VPC. Here, you can see the IP block and other informations that you need to know. That is it. But of course, this VPC is not in Kampala. Where is this VPC located? You can tell. Can you see where this network is located? Yes, but nobody can tell the name. It's in North Virginia, that is in the US. So when you are using AWS, you have to be very conscious where you place your resources. Because you see, this is bound to North Virginia. We have a lot of places. I have South America, Europe, Canada. So North Virginia is the default, and a lot of people don't know this, but that is the most crowded region for cloud users. Nobody wants to change their region. Nobody want to deploy in a different region. They just want to use North Virginia and there's a lot of competition there. All right, so we've created our network. Now let's move on a step. Now let's talk about subnet. So subnet, as I said, is what? Breaking down a larger network into smaller pieces. Remember, these are a larger network, 10.0.0 plus 16. We want to break it into pieces. So let's say we want each of our subnets to have 256 IP addresses. Then we are going to break it down and say, okay, assign this IP 10.0. Let's say 1.0/24. Now, I know you've got a question. You are free to ask. Go ahead. Who want to ask first?
Joseph.
Yes.
I'll go first. Regarding the creation of the VPC in a given region, what key factor is used to select a region for somebody to create a VPC? What's the key factor?
Okay, so there are more factors, not one. But the most important one is the closeness of the region to your customers.
Okay.
So if you are deploying anything in the cloud, a website, an app, and your user base is in China, then it is advisable to select a region in China. If it is in US, then select a region in US. I know we are in Africa. What if it is in Africa? Sometimes, let's look at the AWS Global Network. So AWS Global Network, let me just show you an image of it. And then I will answer this question better. So I'm pulling that here. This is the AWS Global Infrastructure, and hopefully it's going to be a map. Yes, so this is a map of where AWS regions or resources are. And as you can see, this is the African continent. We have one here in Cape Town. You would say, okay, so maybe I am in Ghana somewhere here, and I'm going to create a resource, and my user base is in Africa. So I will go and choose South Africa. Fine. But let's look at the distance from here and the distance to here. Maybe your user base are all based in the western part of Africa. Then presumably you would choose something that is closer to them. In this case, you can see this part is more closer to them. So one factor in selecting a region is the closeness of the region to your customers. And who can tell us why that is important? Why is that so?
I think latency.
Latency, thank you. So if you are driving from, let's say someone is in here, I don't know which country is here, to here, it will be quicker than them driving from there to here at the same speed. So latency, how quickly you get the resource. And you will see this if you watch football online, or you stream a service like on Netflix. Depending on the resource that you are streaming from, but we look at something underrated that is that problem. That sometimes it's slower. And this is visible in watching football. When you are watching football online, you could see that somebody will shout "go" before the goal is scored at your end. I don't know if someone has experienced that. Who has anyway? Who have noticed that?
Yes, I have noticed that on a couple of occasions.
Yes. So that is latency at play. Some people have shorter distance or shorter, and you could think, okay, we are all using the same network, so let's take out the network, because that can also play a role. But that is one. Two, costs. So cost of using AWS resources differ in every region. Say building a house, okay, which AWS data centers are, of course, like physical infrastructures. Building a house in Africa, how much will it cost compared to building the same house in America? How much will it cost compared to building the same house in Asia? Doing business in every region varies. Electricity plays a role because data centers run on electricity. So you also look at the cost aspect. For instance, if I decided, and I have a small tool here, if I decided to show you how much it costs in here, I have the AWS pricing calculator. I'm going to put it in the chat. You can select a region and select any resource, deploy it in any specific region, and you will see that the price differs in regions. So I'm going to create a simple estimate and say, okay, I'm creating an estimate for something small. So I want you to do this because of time. So cost also plays a factor. Then regulation. Some countries, some blocks do not allow their country to host resources outside that block. Like the EU, they have policies regulating data. So if you are in the EU, you are not allowed to deploy resources outside, especially sensitive data. So these factors, and there are more, but these factors kind of plays a role in which region you chose. Have I answered your question?
Yes, you have.
Okay, any other person? Good, let's continue. So as I was saying, we can break this IP down that we want to have 256, 256, and 256 IP spaces. And you have to think of all this before you go and start creating your network. You can use online tools to create CIDR blocks. So that is not something I'm here to teach. Now you can see we have 10.0.1.0. We can have another one, 10.0.2.0/24, and it goes on, it goes on. So how do we do that? Let's put that into practice. We have our network called this. So inside this network, we are going to subdivide the network. So we want to create a subnet. And I click on create subnet and I select the larger network that I want to divide. So I call it the Kampala city. And then I'm going to call this subnet, and I'm going to add a number. So 01 to indicate the first subnet. Okay, I could make it, maybe the use case is to deploy public resources. You can call it public. If it is for private resources, you can call it private, but I'm going to use numbers. You see that we bound the subnet to availability zone. You can leave it at no preference, or I can choose an availability zone. And you see all these availability zones are in that region, not Virginia. No other, you cannot deploy the availability zone in any other region. So I can just choose no preference. It should put it in any one. And then this is the CIDR block. So what is it? I said 10.0.0. I'm using 1. So let me go back to the IP that I've written. Yeah, so I'm using 1. All right. .1. Okay. .0. And then I go in with the /24. Okay. Automatically, you will see this is 256 IPs. But let's do some math here. Let's do some math here. I said to get the total number of IP addresses, you do some computation. Who can do it right now and give us that answer? Just pick your phone, any calculator. What do you think is the total number of IP addresses here? Anyone? So let me help you out. I said it's what? 32 bits. So we have 32 minus the CIDR block here, which is 24. So the number is what? 32 minus 24. People are getting 256, really. So 32 minus 24, that is, let me see if my math is good. That is 8, right? So we have 2 raised to the power 8. Now, what do you get after computing this? 256, good. Charles and Brenda. All right, so let's create our subnet and let's see something. So we are creating a subdivision for the first of our network. Now, when you look at this subnet, there's it here. I want you to pay attention here. We have only 251 IP addresses available. Why? We are supposed to have 256. Why do we have 251? Yes, Jacob.
Yeah, because AWS takes 5 IP addresses.
Thank you. Yes, thank you. So AWS reserves 5 IP addresses. So always you put that into mind. If I decide to choose a CIDR block of 32, how many IP addresses would I have available? So think of that. All right, let's continue. Thank you, Jacob. You can lower your hand. All right, so we see how we can subdivide a network into a subnet, and it's just breaking the larger network in there. let's continue because we have more to learn. This subdivision can be public or private. It can be public or private. So you can see in this case, we have public, then we have private, and we can have multiples of them. Now, what makes a subnet public? Anyone? What makes a subnet public?
I didn't hear that. Can you come again?
What makes a subnet public? Who is lost? If we say a subnet is public, why do you think we are calling it public?
So if I can maybe say public subnet are reachable over the internet, then private is
Okay.
a network that is only accessible within that local area network.
All right, thank you. So when we say a subnet is public, it means if someone comes from the internet or a traffic comes from the internet, that traffic can reach the public subnet, and that is why we say they are public. So now we will look at how that is done. So let's create, okay, give me a second. Is my screen visible? Nope.
No, it's not.
Yes, I accidentally just turned it off. So let me reshare it. And let me know if it's back.
It's visible now.
Is it back? Good, thank you. All right, so what I want us to do is we want to create another subnet. We want to subdivide our network again. So I'm going to select that Kampala City network. And what name should we give this one? What name should we give this division? Someone should suggest a name. Or we should call it subnet 2.
And call it CBD.
That's very weird. Give it a very nice name that you can recall, okay? So we are going to do the same to give it 256 IP addresses. So 10.0.2.0/24. And I am doing this consciously to have always this IP address space available. So I'm going to create this. Now we have two subnets. If you can see, we have subnet 1 and subnet 2. I want to show you something. If I click here on the VPC and I select it, go back and click on the resource map, we will see our VPC called the Kampala City Network. We will see we have two subnets, and then there is something called route table here. Okay, and these subnets are connected to a route table. And then you see we have network connection. What this simply means is that we have our major network, and then we've broken it down into subnets, and we have to configure routes for it to be able to connect either to the internet or to receive connections from the internet. So at the end of the day, we should be able to fill all this from start to finish. So let's go on, and then let's look at the public subnet. When we say a subnet is public, what we simply means is that it can be reachable from the internet. And what makes it reachable from the internet is what we call an internet gateway. So internet gateway is a device that you attach to your subnet, to your VPC. And when you attach it to the VPC, you create routes. So routes are like a map of directions. And then if you add that route to a particular subnet, in this case, so this is a route table, this subnet with the route can know, okay, I can talk to this device, and this device automatically opens door into into the internet. So once you can reach this device, automatically you can reach the internet. So let's see how we do that. So we want to add an internet gateway to our VPC. So how do we do that? Under the VPC dashboard, you will see internet gateway. So if someone asks you what is the use of an internet gateway, say, okay, we use it to what? Open up connectivity to our VPC from the internet and then to the internet. So I click on internet gateway and I say create an internet gateway. I'll call it Kampala City Network. I will use IGW for internet gateway. Okay, so you see that is all. There's no configuration. I can tag it, and then that is done. Now it is floating. It's like a door, a giant door placed in this. Let's come to this. Yes, let's come to this. So you can see this. The internet gateway, it's like this here. You see the gate that you put here. The gate that you put here. So usually we know we have gates in estates. Okay, so this is the internet gateway. And let's say this road is the internet. So let me clean the other resources so that my space is neat. Okay, so this road here, this is the internet. It means it's a highway. Anybody can pass it, anybody can use it, but we are preventing access into our gated community. And we use internet gateway and we use IGW for that. So now that we've created one, let's attach it. Let's tell it where we want it to be. So we attach it to a VPC. So I click attach to a VPC, and then I select the Kampala City Network. Once I do that, you see that now I've attached these gates, this big gate, to our VPC, which is this estate that we've developed. So what do? We will see as we continue. So now we have a VPC, we have a subnet, and then we have an internet gateway. As I was saying, the internet gateway has an IP. Usually it's represented with this IP 0.0.0.0/0. And this IP, usually wherever you see it, represents the internet, or we say all IPs, all IP addresses. Okay, so how do we tell our resources to talk to the internet gateway? Remember, we have two subnets, subnet 1 and 2. Which one do we want to be public? That one is the one that we show how to talk to the internet gateway. So if I come here again to the account, I have my subnets created. If I go here, you see that now I have my subnet. None of them can talk to the internet gateway. And how do we know that? If I click on the resource map, you will see that there is no line connecting them to the Kampala City Network gateway. There is no line connecting to them to that. So it means here, no resource can be able to talk to our gateway, which is they cannot be reachable over the internet. So what do? We create a route table. A route table helps us to configure the instructions that the resources will use to talk to each other. So I come to route table and I click on create route table, and let's call it public route table. I'm going to call it route table so that it becomes nice. You can give it maybe subnet 1 route table, But this route table, we are going to show it how resources can use it for public communication. So it asks me select the VPC. I select the Kampala City Network, and I create the route table. It's created, but once it's created, it doesn't mean anything. You've not attached it to anybody. So I go in, and then you see subnet association, and then you can edit that and associate it to a subnet. So let's associate it to our subnet 1, and then confirm. Now let's go back to our VPC and see what happens with the resource map. You see that now we have 2 subnets as usual, but now we have 2 route tables. And when you create a VPC, AWS creates a default route table for internal routing. So that is the one that you can see here. It's default. It's for internal routing. So you use what we call custom route tables for the configuration. So once it's there, you can see there is a public route table, and which one is it attached to? You can see the line here that it's connecting them. So it means this route table is attached to our subnet 1. What else do we need to do? We have attached a route table, and it is there on the subnet 1. So if we go to the subnet, click on subnet 1, we will see the route tables that it has route table attached to it. So let's edit our route tables and then point it there. And we use IP addresses to point resources that we want them to communicate to. So we come here, we click on routes, so routes, and then click on edit routes. Anytime you create a route table, there is a default route in here. And this default route has what we call the destination, okay? And then we have the targets. Now, what is the destination? This is the same IP address as our VPC. This shows you it's for internal routing, and we call it the local route. It's for internal. That is there, and you cannot take it out. And you see the term local here. So we want to do our own custom route. So we click on add route and look for which IP address we are routing from. In this case, we want to talk to the internet gateway. So what is the IP address we should select? Zero. Thank you, Felix. So we select that, and then we look for the target. So that's the destination. Means all IP addresses, internet. We look for the target, and the target is internet gateway, and that is it. So you see, we have our IGW and the Kampala City Internet Gateway here selected. I click on save, and I go back to our overview to see the roadmap, the resource map, and you can see what happens. Now we have our VPC with 2 subnets, but you see that one subnet has changed color to green. This one, it has changed color to green, and the other one still remain blue. And you can see it's talking to the route table, and the route table is talking to what? The internet gateway. It means right now this our subnet is reachable from the internet, and anything we put in that subnet, like a server, EC2, a database, or anything, can also communicate. It's both in and out, inbound and outbound traffic. All right, it is an hour. I want to give you 10-minute break. We come back and we continue. So everyone who is ready to go on break, put break in the chat, and then you go on. So put break in the chat if you are ready to go. If you are not ready, don't put it. You stay here, and we wait for the others to come back. So break. I can see those who are thirsty. Drink water, drink coffee, take a 1-minute walk. Okay, and then see you in 10 minutes.
Yes.
Okay. Those who are back, you can prompt me in the chat and put one there. And we have about 25 seconds. So put one in the chat if you are back. But I know there is an interesting question in the chat. Yes. Felix is back. Isaac is back. Brenda is back. Some people are not back. I see a very interesting question. Let the 8 seconds pass and then we answer it. And the question reads, this is from Isaac, Jacob, sorry. Jacob says, what are the common pitfalls in configuring subnet, route tables, and internet gateway, and how can I avoid them? That's a very interesting question. And the second question goes like, what tools and services can you use to visualize and manage your AWS network architecture? Okay. Then we have, what best practices should I follow when designing AWS VPC networking? These are all really great networks, great questions. Why am I saying networks? So first of all, let me address I can see a lot of people are back, so let me address the first one. The first one goes like, okay, what are the pitfalls? Yes, there is one pitfall. There is one pitfall that happens. So in here, let's do something small. And I'll answer that question with the pitfall right in front of you. I'm going to create a subnet. Remember, I created a VPC that has over 16,000 IP addresses, and I've taken approximately 500 and let's say 600 IP addresses out of it, which means I have a lot. But I'm going to create one VPC and see something. I select, I want to create a subnet. So I select the VPC, give the subnet name, fill subnet, something like just a placeholder. And here, the CIDR block can be a pitfall. You see, I've seen people just started and they say 10.0.0.0, and then they put /16 here. Jacob, everyone, what can you see here? 165,000 IPs. That is the total number of IP addresses assigned to the larger network, the VPC. So it means you are creating a subnet with the total number of IP addresses. And once you do that, there is no more IP addresses for you to create another subnet. And most people are not aware that this is what they've done, and then they will try to create another subnet, and then it will not work. The same way, we call something overlapping IP addresses. Overlapping IP addresses, it means each subnet must have a unique IP address. What does that mean? The IPs you saw there has a meaning. Let me do that math here for you briefly. And what happens is we realize we have our first subnet at 10.0.1.0/24. And this 24 tells us we have used 256 IP addresses. It means I will not have another subnet with the same subnet address. So if I say 10.0.1.24, and I'm going to create it. Let's see. I'm going to create it. Click create, and I see CIDR IPs overlap. What this means is that there is an IP address range here, and the IPs you are creating will have an IP with the same IP in that subnet. So it's not allowed. We call it overlapping IP. So you cannot do that. Now that leads to your second question. What tools and services can I use to visualize and manage the network? First of all, I have been using one already in the VPC. That is the VPC roadmap. Where is it? Let me see. Yes, the resource map. Those days when we do networking, I think on Windows, from Windows 7, you can visualize, okay, your network map. And the same thing here, so we can see what is happening. But then there are other resources like CIDR XY that you can use to create your CIDR blocks. So one thing is plan your CIDR block before you come in. Yes. So this, let me put the tool in the chat. And there are a lot of online tools that you can use to create. So select a large IP block and then tell it you want to create 4 IP addresses, and then you can use that to do that. There are a lot of them. Everyone has their own one. I use different ones. And today, with the exception of generative AIs, you can say, okay, I want to have 4 subnets, each with 30 IP addresses. And then you are good to go. It will create it for you. And then move on to the third question. The third question is, what best practices do I follow when designing my VPC? Create large VPC network, okay, so that you don't run out of it. That is one. And we will look at other best practices like security, and that is the next few topics we will talk about as we go on. I think Henry also says, are there any performance consideration that should be taken into account when creating a VPC? The only consideration is the location of the region which can affect how your customers use your resources. Now, we are diving to other advanced means of networking as we go on, and you see some are more advanced in there. We have different types. This is not the only thing we can do. What are the cost factors to be taken into consideration? Good, that's a very good question. Everything here, I think until this year, AWS has started charging for IP version 4, but it is very little. So let me go to, when I go on here, you can see I have incurred a lot of costs on AWS, but I'm not worried. These are planned costs there. And if you look at the bill, I want to show you my bill. If you look at the bill, you see under networking, there are specific items that are billed. And one of them is Elastic IP. It's Elastic IP. So I'm going to go to bills and show you that. And whilst you are waiting for that, Wenda says, I know when you go to the console, there is a default VPC created for you. Yes, there is no disadvantage, but you see that has dedicated IP allocations for you. So customization, and remember, you can segregate different workloads in different VPCs. So I have deleted that VPC in my account. That's why you see only one VPC. But it's good to have that one there too, because there are some services that would want to use the AWS default VPC. But there is no disadvantage to using that aside from you having control and customization. Okay. So here in my bill, I want to focus on networking. Yeah, virtual private cloud. And here you see I have incurred around $5 under the virtual private cloud, but don't worry about the $5. Worry about this 5.4 in Ohio. And you can see what I have been charged for, and that is the IP addresses. Okay, and here when we are talking about is usually the elastic IP address. It is a reserve IP address that you reserved. And that one, the moment you don't use it, you pay for it. When you are using it, you don't pay for it. Why is that so? We will understand that as we go on. Anyway, thank you very much for the questions. I think they are very interesting. Shall we continue? Thumbs up so that we continue. We have only few minutes remaining. Good. All right. So we look at route tables, and I've already shown you that, okay, your VPC by default has a route table. We usually refer to it as the implicit router. There is a router that we configure the route tables on, and we call it the implicit router. So just know that your VPC have a router, just that we don't talk about that, because it's not really important to the level that we are talking about. We look at public subnet, and we say public subnets, for them to be public, need to have access to the internet gateway. Means they need to have a route to the internet gateway. What about private subnets? Private subnets do not have access to the internet gateway. So as you can see in this route table here, there is no internet route to the internet gateway. And what resources do we put in the private subnet? Any idea? I know you learned about compute and databases. So which one do you think we put in there? Yes, Jacob, go on.
Yeah, so databases, because they need not to be in the public subnet. And then I think database is what comes into my mind at first.
Yes, databases, backend servers, okay? Backend servers, you don't need to put them in the public subnet because they are sensitive. So we put them in the private subnet. Then we have the public subnet, front-facing, internet-facing servers like web servers, app servers are all in the public subnet because people will access them from the internet. So they need to be here. Is that okay? Now, when you look at this, you see that we have resources we put in the public subnet have two IP addresses. We have the public IP and then we have the private IP. And the public IP is what is used for routing over the internet. Private IP is used for internal routing. So in the private subnet, only private IPs are available. Take note of that. Now, I want to talk briefly about elastic IP addresses because of time, I will be speeding a little bit. Don't worry, you can rewatch the recording. And these are facts that I'm speaking, so you don't need to really worry about that. Now, elastic IP have a very simpler name. If you have done networking online, offline, we call it static IP. That is IP addresses that do not change. Public IP addresses are like public seats available in a cinema. You sit on it, once you occupy the seat, they are assigned to you. You stand up, that seat is no longer yours. Another person can come in and use it. So if you have a server in your subnet and that server shuts down, it loses its IP address. If you terminate it, it loses its IP address. You restart it, you lose the public IP. And then the next time the server comes online, it is assigned a new IP address. So imagine if there is a server that wants to talk to your server. So a server here, wants to talk to your server, and your server's IP is 10.0.2.4 something. Okay, this is your IP, and this is what it's talking to. The traffic is going, and then this server goes down, and it comes up, and then the IP address changes. How does it get to it? So web servers and servers that we don't want them to be changing IP address regularly, we assign them static IP addresses. And that is what we call in AWS elastic IP. You can attach it to a particular resource, take it and go and attach it to a particular resource, and that is why we are calling it elastic in AWS. But it means IP address that does not change. And in this case, you have reserved that particular IP, so you pay for it. So as you look at my AWS bill, I am being charged for that IP. Now, remember when we were looking in the beginning about MAC addresses and stuff, I said that there is a physical device in our computers that has the MAC address attached to it. Who can remember the name?
Come again, you said?
So in your computer right now, there is a physical device on your computer that allows your computer to be able to connect to a network. Do you know the name?
Okay. It's called NIC, or not,
Yes, NIC.
network interface
Network.
card.
Good. And network adapter, network card. In AWS, when we are talking about elastic IP addresses, because we can move them around, usually they are also attached to a network interface that we can attach to servers. So we will look at them as we continue. In the next slide, we call them the elastic network interface card. So this is a virtual network card. Okay, this is a virtual network card that if you have a server, this is a server, and I want to attach an elastic IP address to it, I just assign it to the network card and I can go and attach it to it. I can take out that network card and go and attach it to another server. And we call this a secondary. The one that we can move about is a secondary ENI. If you launch a server, it has a primary network card, like the one inside your PC. You cannot take it out. But imagine if you have, we have USB ones. We have USB network interface cards. So when we use the system unit, the old system unit that does not come with network cards, you can just go and buy a USB one and come and plug in, and your device have a network card. You can take that and go and plug it into another device, and that device has a network card. So the same thing happens here. And the elastic network interface is our virtual network card that we can be moved around resources in the same availability zones. And the IP address is the same. It maintains its IP address, and it also has the MAC address. I like a question from Wenda. It says, so what if I need to access the database using a tool like MySQL Workbench? Do we need to expose the database? No, you don't. Databases have endpoints. So if you are using MySQL, you have endpoints, and that's what you connect to. Remember, we will look at a way we talk to resources in the private subnet, and then we will also look at the VPC endpoint thing that I just mentioned. Okay, so that is how this works. But there is something that happens, and that is to answer Wendel's question. We have our database running, MySQL running on the server in the private subnet. And we want this server to be able to go into the internet to download patches, to download updates, to download softwares. How do we make this happen? Because remember, they have no public route. So we use a tool called the Network Address Translator, or the NAT gateway. Sometimes you will see we have a NAT instance. It's the same thing, but one is you yourself doing it. So maybe I pick a server and configure it to perform the functionality of a NAT. We call it a NAT instance or a NAT server. But AWS have their own managed server that performs the functionality of address translation, and we call it the NAT gateway. What is address translation? If you check your IP address, everybody, can you check your IP address and put it in the chat? Check your IP address and put it in the chat. I want to check my right now, and I click on my Wi-Fi, go to properties, and I'm going to put my IP address here and show you something. Everybody put your IP address in there. What you can see as your IP, put it in the chat. Okay, I see 192. And off the bat, I can guess a lot of you are going to, all of you are going to put 192, 192, 192, 192, 192 in there. Like me, all of you are going to put 192, 192, and that is a class of IP address we call the class C, which is for private IP address. Okay, let me get mine. So mine, I want to put mine in. I can see a lot of 192, 192, 192, but I want to talk about mine for a reason. So where is mine? Now, whilst you are doing that, mine is also 192 and blah, blah, blah. But I want to show you something. Go to Google. Go to Google. And I'm doing that. I'm going to Google. Mine is also 192 and blah, blah, blah. I'm going to Google and say, find my IP. Just in Google. And you see that I'll be having, okay, in Google, you should have that right in there. You don't need. So you see what I'm having. Okay, this is my IP address. Why is that so? Everybody check yours. You see it's different. And the reason is that IP addresses, we have public and private. Thank you, Jacob. So we have public and private. So we have private IP addresses, and then we have public IP address. And when you check your computer, you see the first IP, you see the 192.168.1. something, mine is 2, is my private IP address. When you pick an IP address, we have, it tells a story. It tells you the network and then the host. So we say this is the network ID, and this tells you the number of, if you are number what on the network. So if you see 2 here, it means you are the second device on your network. Mostly your router, which we call the default gateway, will have number 1. And then this number you see usually talks about a subnet if it is there, but I don't want to go there. Now, how come the same computer has this IP address and have another one, 4.41.210.141 and something? How is that possible? This one is for routing to the internet. And then the local one is for routing on your network, the one that you are using in there. So your Wi-Fi is a local network, and that's a private network. Traffic there do not go into the internet. So if you want the traffic to go into the internet, you need a network address translator. And what it does is that it maps the traffic. So this is 192.168.1.2. It maps it, it gives you a public IP address. So public IP addresses are actually assigned by your internet service provider. It's not you. That is assigned, and that is it. So if somebody wants to talk to you, they talk to this public IP, and when it gets there, your NAT will say, okay, this person is talking to me, but behind me, what are the computers behind me? It is this one. So let me forward this traffic to it. That is what we call network address translation. So in this instance, we have a server here that has only a public IP, a private IP, 17 something here. So what do you do if you want this server to reach the internet? So we let it talk to the NAT gateway, which is like a backdoor. And the NAT gateway is usually in the public subnet. So it has an elastic IP or a public IP and a private IP. So they can communicate with the private IP and say, okay, I want to access this website. Help me out. Then the NAT gateway say, okay, good. Let me talk to the internet gateway because I can see it. I'm in the public subnet. I can see it. Talks to the internet gateway and then send that traffic to the resource on the internet, which is a public IP. Now that resource responds and then gives the response through the internet gateway back to the NAT gateway, and the NAT gateway maps it to what? Your device over the private IP. So the NAT gateway acts as a security firewall in there because it allows this traffic will only work if it is initiated by the resource in the subnet. It's a one-way traffic. You have to initiate it from the subnet before it is allowed. But anything in the public subnet can be spoken to, can be connected to in and out. Whether it initiates it or another resource initiates it, it can be connected to. So the same thing happens in, you can use it in databases as well. So if you have a server and there's a database in there, you use a NAT gateway, and then this database will talk to the NAT gateway, and then the NAT gateway will talk to wherever you are connecting from. So if it is, this is you, Wendell, this is you here on your laptop, you pass through the internet, and then you want to talk to your server using, usually databases have endpoints. So the workbench on your computer is using your network. So it's connecting to the endpoint, which is an IP address and a port number, usually. So that communication goes through the NAT gateway, okay? But here, because it's a database, it initiates that. You get it? So this is what happens. You can also use endpoints, and you look at that as we go on, as we go on in the chapter. I hope that's answered your questions. So how do we create a NAT table? In my VPC console, you can see it's a NAT gateway, not a table, please forgive me. So I can see NAT gateways here. Click on it, and what I'm doing is create a NAT gateway, and this is one thing that incur cost. So usually when I don't use it, I delete it, release it to release the elastic IP. If you keep the IP, you are going to pay for it. When you are using it, it's a public IP that everybody is using. So I will call it Kampala, and I'm just going to use NW, NAT gateway, NWG. Yeah, like this. Select the subnet that I want to put it in, and I want it to be in the public subnet, okay? And it's a public for public connectivity, but it's going to interface the resources in there. And then I allocate an elastic IP because the NAT gateway don't need to be changing the IP addresses. So I allocate that, and you see that IP actually goes with the ENI, and then create that. So once I create this, let's look at something here again. Let's look at our resource map. You see that now we have the same things, and then we have what? A NAT gateway here. But you see, it's not connected to anything. So we have to route it. We have to route the traffic in there. So I can go into my subnet 2, or let me create a custom route table and call it for subnet 2 route table. So let me call it private route table and select the VPC and then add this. So now in the private route table, I can associate it, edit association, and associate it with our subnet 2, save that, and then come back and then edit the routes. So in the routes, I'll edit the routes, and here I'll add another route. Because the NAT gateway is also going to talk to the internet gateway, we use this IP address. But then now I look for that resource and say the NAT gateway. So I have one NAT gateway here, and see if that changes. Now, if I go back to my VPC and look at the resource map, I should see that I have all these resources, you see. So if any resource is in the subnet 1, it will talk to the public route table, and as you can see, it will talk to the internet gateway. If I have any resource in subnet 2, it will talk to the private route table and talk to what? The NAT gateway. In this sense, the NAT gateway will allow you to talk to the internet. So you see, now we have a way of allowing the resources in the private subnet to talk to the internet gateway. That is what you can see here. Okay, now the next thing we want to look at is, okay, now we've seen how to create a network, how to allow, make a subnet public or private. How do we protect these subnets? How do we protect our VPCs? And that is how we want to do. How do we filter traffic coming in and out of our resources? That's the next thing I want us to talk to about. So the first way of filtering is, one, I want to draw this. Okay. So we have internet. Usually I draw the internet like the cloud, and my cloud looks really scary. The internet. Then we have traffic from the internet to our VPC. And there is something in front of the VPC called the internet gateway that allows this communication to be possible, VPC. And then inside that VPC, we have subnets. So let's say if this is a public subnet, traffic flows to the public subnet. How do we protect this? The internet gateway is a gate already acting as a layer. The subnet also has a gate acting as a layer, but we use what we call firewalls to protect resources. And one of that firewall is what we call the network access control list. All my life, when I've been using, I was a network, an IT personnel for an organization before I joined cloud. I use this access control list to do something simple. All the workers in the organizations have working computers. And even though our network is password protected, I still take the MAC address of all these computers and put into what I call the network access control list. So there is a list of all the devices there. And if you have the password to the network, the Wi-Fi, and your MAC address is not in that list, you will never be able to connect to the traffic, to the network. Even though you've entered the password, it will not. Only those with the password and then their MAC address in that list are those allowed to connect to the network. But this is totally different in cloud. But you can see what that can do. You can also block specific MAC addresses there. The same thing in AWS, we can protect our subnets. So network access control list protects the subnets. To protect the subnet. And it's like a filter we put in front of the subnet, and we control the traffic coming in and the traffic going out of the subnet. This is a very strict one. Now, how do we do that? We do that by configuring what we call allow or deny rules. So we say, okay, this port and this HTTP protocol, either allow it from this source of IP address in the internet or deny it. NACLs, or what we call the network access control list, you need to configure both the inbound and outbound traffic. And because of that, we say they are stateless. They are like the passport control office. Before you go into a country, you need to have a passport that says you are allowed to enter into the country. We call it inbound. Before you come out of the country, you need to have a passport that says you are allowed to leave the country, outbound. So NACLs are stateless. They don't say because you came 1 week into Kampala, then you can just come out and go. No, every time you come in and you are going, they will check your passport to make sure you are in the list of people allowed to leave the country. And when you are entering into the country, they check to know if you are in the list of people allowed into the country. So we use that to protect the subnet. So every traffic that comes into the subnet, we can filter it and only allow specific traffic into our subnet. Then we go on another step and say, okay, in this subnet, what do we put there? Servers, of course. Database server, EC2 instances, anything we put in there, we need to protect it. So we use what we call security groups, which is another firewall that is attached to the servers. And we say it protects at the instance level. Security groups are a bit less lenient than NACOS. For them, by default, when you create a security group, what happens is that it can talk to any resource you want to talk to. But before you can talk to it, you should be allowed to talk to it. So incoming traffics are controlled in security groups. So security groups don't have allow and deny policy. They have allow and no policy at all. So if you don't have any policy, it means you are not allowed. So that is how security groups works. And we say they are stateful. In the exams, you are going to be confronted with this. So notice, NACOS are stateless. Security groups are what? Stateful. What it means is that once you are like your doorman, once you come in and you employ your doorman, if you are coming, oh, it's you, Miss Brenda, they open the door for you. Oh, anytime you are coming in, it's you, Edward, they open the door for you. But NACOS are like the COVID protocol team, okay? Even though they allow you into the resource, they take your temperature, they make sure you have your vaccination cards. If you are living again, you need to do COVID test before you leave the country, or your passport. So that is how NACOS and security groups work. And we use all this to protect our network. So this is what we call the layer or the layered defense or the onion protocol. Terence used to use that word a lot, the onion protocol. And you see, if you open, you peel an onion, there's another peel, you take that one, there's another one. So if you are coming into our VPC with your laptop, okay, you go into the internet gateway because you are using the internet. The route tables will transmit your traffic to where it's supposed to go. NACOS, which are off by default, you have to on them if you want to, will filter the traffic. Is your IP blocked? Maybe your IP is 40.0. something. Is it part of the allowed IPs or is it denied? If it is part of allowed, then it allows you to go in and then talks to the public subnet, which the route tables are at play here again. Then the server you are targeting, the security groups will say, okay, is this man allowed to come in? They check your resources, your credentials against the security group policies. If you're allowed, they allow you in. Now you've reached the server. The server says, okay, received, traffic received. Maybe it needs to talk to you back, response. When the response is coming, security groups don't care because once they know you have been authenticated in, they can talk to you. So they won't say anything. The traffic goes in again and comes and NACOS will say, wait, where are you going? Who are you? You can say, okay, I'm the one who just passed by. You say, oh, I don't know you. Please bring your documentations. They check again before they allow that traffic come all the way to you here. So this is a lot of protections in our VPC. So to answer your questions in VPC, this is the layered defense that we have, and you can configure all this. So if you are comparing security groups and NACOS, you will see that we say the security groups the support allows rules only. NACOS have to allow and deny. And the only way of denying something in security group is you don't have it there. That is the only way. We say security groups are stateful, NACOS are what? Stateless, and many more. Now let's do a little bit of knowledge check, and then I see if you are following. All right, I've covered the basics of networking. Let's see. True or false? Put your answer in the chat. A single Amazon VPC can span multiple regions. True or false? Means can a single VPC span multiple regions? True or false? Everybody answer. A or B? False, 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 false. I want everybody to answer. We are 13 here, except of course the bosses, they know the answer. All right, so the answer is false. The security group VPCs are bound to one region. So you cannot have a VPC that covers 2 regions though. The next question is, which actions must be taken to make a subnet public? Which action must be taken to make a subnet public? We have A, route outbound traffic from the subnet. B, route inbound traffic from the internet gateway. C, route outbound traffic to the internet gateway. D, subnet are public by default. What will be the answer? I see Brenda says C, a lot of C's. You people are really good. That's really good of you. Okay. Which function does the NAT gateway serve? A, it load balances incoming traffic to multiple instances. B, allows internet traffic initiated by private subnet instances. C, allow instances to communicate between subnets. D, increase security for instances in public subnet. Okay, so everybody is following. That is B is the answer. All right, the next question. What should be used to create traffic filtering rules for the subnets? Now, I've just covered about 5% of your exam questions already. Is it NAT gateway, route table, security groups, or NACOS? Okay, I'm seeing a lot of these. Don't follow the democratic people, okay? If you have a divergent answer, put it in. All right, which ports are open by default when a security group is created? I did not mention this, but let's see if people can answer this. Which ports are open by default when a security group is created? You are selecting to A, nothing is allowed inbound. B, nothing is allowed outbound. C, anything is allowed inbound. D, anything is allowed outbound. E, inbound traffic is allowed on public subnets. I see D, anything is allowed outbound. So people are saying D. So let me see if it is D. So people are saying D. And you are choosing 2 answers. So you choose A, B, C, or A, B, C, or D, C, or something. So a lot of people are saying D. That is one answer. We are choosing 2. C, D. Somebody say anything is allowed inbound. Okay. That is window. All right. Anybody else? What is your second answer? Brenda, Felix, Jacob. Felix says, Jacob says AD. So Jacob says AD. Okay. And Wendell said I should wait. So I'm waiting, Wendell. Don't worry. What about you? Olu. Sorry if I butchered your name. Olu Fabajo. You have not responded yet. Edward, I have not seen you say anything. Charles, you too. Try your luck. Okay, and there's no wrong or right answer. So just put something in the chat. Let me see who has not said anything today. Yeah, Ray, you are also quiet. Okay, now people are getting the hints. So yes, the answer is AD. By default, security groups have blocked all inbound access. You have to specify, and we do them one by one. We don't say everybody should connect. No, we specify the specific resource that can communicate. Then we say anything is allowed outbound. So we are selfish. Our server can talk to anything that he wants to talk to, but you cannot talk to it if we don't allow you to talk to it. All right, so thank you very much, everyone. That brings us to the basics of networking in AWS. But there are more advanced concepts that we can cover. And because of time, Terence, I need you here. We have about 2 minutes. What should I do? Because I have some few things I want to talk about, some other things, or if we can do it next week as well. That's okay. Or your class rep, who is there? What do you think? Do you think you want me to have another 15 minutes to finish it, or I can come and do it next week?
Now we can continue.
Okay. What about the rest? Maybe some people are hungry. Do you support Brenda's posture that we can continue?
I think if it's 15 minutes, we're able to support that and
Okay.
complete.
Okay. All right. Thank you. So 15 minutes, I'll try my best. I like to teach, so that's why I move pretty slow. I don't lecture. All right. So let's look at few other means of what happens. So we can connect to VPCs without using the internet. Okay. We can connect to VPCs and keep our connections secure. Or we can allow connect to specific resources. And VPCs have what we call VPC endpoints. So you've watched movies, okay? You've watched movies where there is teleportation, where people just enter into a door and boom, they vanish, and then they go and appear at their destination. In Africa, we call them witches and wizards. Okay, they vanish. This is how VPC endpoints work. So every VPC, you can create an endpoint, and then you can connect to that endpoint privately, because usually if we want to talk to VPCs, we have to talk through in the internet gateway, and then to the subnet. But let's say you have a DynamoDB that is somewhere. You have an S3 bucket that is somewhere, and you want it there outside your VPC, and you want them to communicate to your VPC. You can create what we call a VPC endpoint, and these resources can communicate securely using the AWS backbone network, which is a private network, without using the internet. They are also managed by AWS, and they are highly available. So as I was saying, we can create endpoints to talk to. We have two types of this endpoint. We have what we call the gateway endpoint and the interface endpoint. One thing you should know, and I always give this, is that this is newer. The interface endpoint is the newer version of it. So it supports more resources than the gateway endpoint. The gateway endpoint was designed to allow resources like Amazon S3, DynamoDB. Only the two of them were supported. So if you want to use private endpoints to communicate to these resources, you use the gateway endpoint. But then we have the interface endpoint that was also created, and it supports more resources than the gateway endpoint. And it is powered by what we call AWS Private Link. Private Link is something that can also come in networking. And what it simply means is that it's a network connectivity that you can create to talk to resources using the AWS backbone network without using the internet. So if you want to connect to resources privately, use the AWS private link. And the interface endpoint uses that private link. But the gateway endpoint before that, this is advanced stuff, so don't worry, just pick the points that I'm mentioning. The gateway endpoint usually uses the IP addresses of the resources, or what we call the prefixes. So you see in the route table, we create an interface endpoint and create a prefix, and the prefix is talking about, okay, the destination is, and there's three buckets here. The destination is DynamoDB, and then we configure the route tables to talk to them. But in the gateway endpoint, we are using something different, okay? Because it works with private endpoint, we can put a gateway, the interface endpoint in our subnet, and we can talk to it using the means we used before, or we can directly talk to a different AWS using that endpoint without passing through the internet gateway. So that's basically about these two things. So take of endpoints in that sense. Also, we also have a way we can connect multiple VPCs. So we can have VPC A. We can have about 5 VPCs per account. I'm not drawing a square, I'm drawing a VPC. My whiteboard wants to draw a distance. So this is a VPC A. Let's say VPC A. We have VPC B. And we can connect these two VPCs so that the resources among them can talk to each other. And this is a secure connection. This is a secure connection, and we call this, if we are connecting one VPC to another, we call it VPC peering or peering, as someone will call it. So VPC peering is where we connect two VPCs, two or more VPCs, to talk to each other. But we have different ways of doing so. The peering only connect one VPC to another VPC. So this VPC A can talk to VPC B, and then let's say we have VPC C here. So let's say this is VPC C. We can also connect VPC C with VPC A. I've got a question. Now we have VPC A connected to VPC C, VPC B, and VPC A connected to VPC C. Do you think VPC B can talk to VPC C? Yes, Jacob.
No, because there has to be an explicit connection between peering between VPC C and B.
Yes. So we say VPC peering does not support transitive connection. You have to specifically connect it to only one VPC and then connect it to another. So it means you have to configure this VPC to also talk to this, or it will not be transitive. That is VPC peering. What happens is that when we connect, we create a peering connection, and let me go here. So if we have multiple VPCs and that here, let me go to peering. Where is it? My eyes are growing tall. Let me filter peering or peering so that I can get what I want. When you are creating a VPC peering, the two VPCs, one initiates the connection and the other accepts. So the one that initiates, we call it the requester, and the one that accepts the connection, it's the acceptor. So sometimes you should know this. So one VPC have to send a connection request, and then the other accept the request. It is really weird. Everyone, see if you can see my screen more than me. Where is my peering connection?
Maybe try under the VPC section. I think you're scrolling down up, maybe at the very beginning.
Yeah,
Under
I know it.
VPCs.
Yeah, I know it's there, but just that I can't see it.
If you scroll up back to the VPC.
Yeah,
there,
so
the
here it
last
is. Yes, thank you. Thank you very much. My eye is dull. So this is the peering connection. So if I have two VPCs and we use this, if we don't want to be creating resources duplicates, you can have a server here and another server there, and you want them to talk to each other, then you can create a peering connection. And as you can see, you select the requester, and then when you send, the requester accepts. You have to go and accept that manually, and then the VPCs are peered, but not so. They are not peered by default. You have to now configure their route tables. So in the route table, in this VPC, if this VPC have an IP of, let's say, 10.0.0.0/16, this one has 172. And VPC peering should also not have overlapping IP addresses. That is one rule. So it means in this route table, you have to bring the VPC. If this one is talking, this one should have the VPC-C route. And then in the VPC-C route table, you should also have VPC-A route table, a route to be able to talk to each other. And as I said, VPC peering is not transitive. So because VPC-A can talk to B, doesn't mean it can talk to C. You have to create another route connection to that. So if we want to be, okay, yes, Jacob, go on.
Yeah, so what about if maybe one with VPC is on /8, will it communicate with the one of /16?
/8. So remember, /8 is how many IP addresses?
Let me just get that.
So usually the highest you can get is /16. I know if I want to teach IP addressing and subnetting, that's something that will take us away. That's why I say just use the resources tools to create your subnet. But the highest you get is /16.
Okay,
Slash
so
16 means you have the largest network, and then slash 32 gives you only one IP address. So you look at the classes, you see that I've written 10.0, and I started with another class like 172. Look at it. So that's a different class of IP addresses. You can use different classes as well.
Yes, I agree, but I'm just saying that, okay, in case one VPC is maybe says, so, okay, maybe this one is 16, then maybe the other one is maybe slash 18. Will they communicate? Because I've had scenarios where if you don't configure the same like slash 16 on both VPCs, there may be some trouble with communication. So I just wanted to clarify, is that a hindrance?
Yes,
Or no?
yes. So if you use, let's say slash 8, and let's say you use slash 20 for different VPCs, because VPC with less, I want to be very good in this. Let me use slash 24 and slash 16. Do you understand? Now, as I was saying, the IP addresses are different. So if I say 192.168.0.1/16, of course, this is giving me 65 IP addresses, but this is a different class of IP address. This is a different network. Okay. And then if I have 10.0.0.0/16, this is also a different class of IP addresses, which means the network IDs are different. So they may not overlap. But if you have a large network, let's say you are using the same 10.0.0, then whatever you should have here should not be in here. So you can have a subset that is not part of this. So it will work.
Okay. Thank you.
Yeah. Okay. All right. So what are the benefits of VPC peering? You want to use them to bypass the internet gateway or the VP, virtual private gateway. We look at what that is, and you want to have private communications between your VPCs. It makes your resources, the network speed faster. This way they can communicate faster because they are using the AWS global network, which is a high speed network to communicate. And if you want to use private IP addresses to communicate between your resources, you can do so. Now, that is what happens. But then there is another thing that happens. We have somebody, and this is actually the real use case of cloud. So you have to be diving into this area. Most companies have an on-premises data center. And because they have already provisioned that they cannot destroy it, they want to add cloud to augment. So they are using AWS. How do they connect to AWS? They want to connect their servers locally to the cloud. So they use the hybrid networking approach. Of course, they can do so through the internet, but organizations want to protect their data. So we can have what we call the AWS site-to-site VPN. What is a VPN connection? The class is very quiet. I want someone to explain that. What is a VPN connection? Yes, Jacob, go on.
Yeah, so VPN connection is a layer onto the existing internet connection, which provides like protocols like IPsec. So this just virtual private network that provides connections between two endpoints. Yeah.
Okay.
That's the way.
All right. All right, thank you. So VPN connections also uses the internet in this case, but they are protected. So think of the biggest highway in Kampala. Every car uses it. But if your president is passing on it, what happens? They go with a convoy with the whole security team so that nobody can hurt the president. That is what VPN connections work. So they can decide to create what we call the AWS site-to-site VPN connection to use the internet, but the connection is encrypted and they are using the VPN protocol to protect it. In this connection, they need two resources. They need what we call the virtual private gateway, which is a device like the NAT gateway you create in your AWS account. Then you use your customer gateway. This can be a router in their data center, and this can create the VPN connection for them to talk to AWS. So this is a hybrid connection. Then some people don't want to even use the internet at all. They want the communication not to pass through the internet. So they use what we call the direct connect. So direct connect is where they lay physical fiber optic cables all the way to the company's data center. And how does AWS does that? AWS have what we call direct connect location partners. So there are partners, organizations that render the direct connection. So AWS already with their global network connect physical cables to that partner. And then if you want, and this is very expensive, but you know, some organizations, expensive doesn't mean anything for them. For some organizations, it is, but for some, it is not. So they lay physical cables to their servers and then connect to a cage in the direct connection location. And then they connect, this is the customer's cage. So the partner have a cage there, a router in that cage, and they connect to that router, and that router connects to the AWS router. And then every traffic is passing through that cable to AWS, not through the internet. So this is the highest form of speed you get. This is very fast speed and it's very secure. Unlike using the internet, VPN and these are very secure, but this is the direct connect is faster. Okay, so it supports up to 100 gigabyte per second of connection speed. Okay, meanwhile, the side-to-side VPN have up to 1.25 gigabyte of connection speed. And this one, you need to have an agreement because it takes months to set up the connection. So these are another way of connecting hybridly to AWS. My 15 minutes is up, but gracefully, I have one thing I want to talk about, and I'll give the rest to you as an assignment, and I'll come in one day to ask for minutes to talk about it. So remember, we were saying VPC peering connection is one-to-one. It's one-to-one. So if you have multiple VPCs you want to connect, maybe you have direct connect, you want to add to it, becomes difficult. So there is an AWS service that supports what we call transitive connection, and we call it the transit gateway. And the transit gateway allows us to connect multiple VPCs. So it's like a hub. It's like a hub or a switch on the network. So you can connect your VPCs to it, and then it can facilitate the communication. In this way, you can connect another VPC, another VPC. You can even add a direct connect network, a VPN connection, and it will perform the routing of all the resources. It allows us to connect up to 5,000 VPCs. All right, and what happens is that it manages the route tables for us. So it is pretty easy to create a direct connection. The resources, the VPCs and those things we attach to the transit gateway, it's called our core attachments. So when you want to attach a VPC, we call it an attachment, a VPN connection, an attachment, a transit gateway, an attachment, a VPC, an attachment. We call them attachments. All right, so I would like to end here for the purpose of time. I think the 15 minutes is on. Do you have any questions? Thank you, Jacob. I think Jacob is saying thanks for the delivery. Please, you can rewatch the recording and take notes. I've given you notes in the speeches. Those are like exam. In Ghana, we call them exam tips. So thank you very much, everyone. I hope there are a few things left, like the content delivery. So read about CloudFront. So CloudFront, and then Route 53. And then the last one is AWS Global Accelerator. There is no better resource than the AWS documentation. So go online, search for AWS documentations, CloudFront, and everything about it is there. Thank you very much, everyone. And I hope you enjoyed this session. Terence, if you are here, I hand over to you.
Thank you, Joseph. Thank you, Joseph. Yeah, Terence is here.
Yeah, thank you, Joseph, and thank you everybody for attending. I'm immensely grateful for your delivery. I will slightly discuss with Isaac and Brenda and the team Darius, such that next week maybe I could try to do content delivery, then introduce migration and transfer. So for CDN, I will do CloudFront, very important. I will do Route 53, equally important, as well as Global Accelerator. Then after that, introduce migration and transfer. Why I'm saying that is those three, okay, we overestimated on our side and our planning because networking in AWS is very large, as well as content delivery. When the two are combined, are too big. So maybe with your permission, Brenda and Isaac and Darius, we may jig that particular delivery slightly to ensure that we do you justice. Away from that, why I'm thinking that way is because migration and transfer is wide but not impossible, extremely theoretical in terms of delivery. So we will look into what needs to be looked into. So over to you, Brenda, Isaac, Darius.
Yes, thank you. Thank you, Terence. I think we'll have a discussion with Isaac.
Okay.
And I don't know if anyone has any questions. You can post them in the chat or you can unmute.
It seems everybody is okay now that no questions are being asked. And if no question is being asked, I just wish all of you a very restful weekend. And we link up next week. I'll be in touch with the moderators of the user group on email again over maybe tomorrow.
All right.
Thank you. Thank you.
Thank you, Joseph, once again. And thank you, Terence, and everyone for attending.
Bye-bye.
Thank you, everyone. It's nice to have you. See you sometime. Bye-bye.
You.